I welcome you all of you for the dairy engineering course. I am Dr. G. Ratinam, working as an assistant professor in the Department of Food Technology in the Stan College of Engineering and Technology, Coimbatore. So today we are going to see about the topic in the dairy engineering courses, cream. Let us start with the contents. So the contents covers with the what do you mean by a cream? So classification of the cream, chemical composition of cream, physico-chemical properties of cream and types and its manufacturing, packaging, storage and distribution of the cream, the purpose of cream separation, the principle of cream separation and different types of and methods of cream separation techniques, the quality of the cream and its application in the cream processing. So what are the applications that is present in the dairy oriented and also the other dairy processing, the application of the cream which is to be mentioned. So what do you mean by cream? So cream is a skimmy layer that is obtained in a raw milk after we are keeping the milk in certain time. For example, after the milk which is milked from the cow or buffalo or any other milking animal, the milk which is kept as undisturbed for some time. So after some time, the layer which is formed on the surface of the milk, which is called the creamy layer, and we can obtain the cream from the layer which is formed on the surface of the milk. So that is called as a cream. So cream which is produced by skimming the layer of the fat or any other substance which is present on the surface of the milk. That portion of milk that is raised on the surface which is rich in the fat, so we can obtain the fat or cream after some time when the raw milk which is kept undisturbed for 3 to 4 hours. And when the application of a heating process or a cooling process, we can found the layer which is present on the top of the milk. So this is because of the density difference that is happening between the milk. It means between the solid particles that is present in the milk and the water. So the classification of cream. So based on the percentage of fat or milk fat that is present in the cream, we can classify the cream. So market cream, which is directly obtained from the dairy or milk processing. After processing the milk, we can obtain the cream directly. So that is called the market cream and we can consume directly. And manufacturing cream. So the cream which can be obtained from the other dairy related products. For example, the cream which can be used for the preparation of the butter, cheese or any other substance which can have a more application on the cream. So that is called the manufactured cream. Based on the consumer preferences, we manufacture the cream and we can apply over the certain products. And as I told, based on the percentage of fat, so if the cream which contains 20 to 25% milk fat, so then it is called table cream, light cream and coffee cream. And if it contains 30 to 40% milk fat, we call as a whipping cream and a heavy cream. And if it is contains 65 to 80% milk fat, then it is called a plastic cream. Let us discuss the chemical composition of the cream. So based on the fat percentage, we can categorize as a low fat cream and high fat cream. So low fat cream has a constituents of water, the percentage level as 68.20, fat as 25%, protein 2.50, lactose 3.71, as 0.56, total solids 31.80, solids not fat 6.80. And coming towards to the high fat cream, 45.5% water, 60% fat, protein is 1.69 and lactose is 2.47 as 0.37, total solids 54.55 and solid not fat is 4.22. As we mentioned below, the higher the fat in the cream, the lower the SNF. So higher the fat percentage the product has, lower the solid not fats. The source is from the dictionary of dairying, and here I mentioned one other, the raw milk which contains a percentage of fat in the range of 3 to 5 depends on the milking animal, and it contains the percentage of fat that is present in the cream is 33%, 33 to 35%. So the fresh raw milk which contains a cream that has a fat percentage of 33%. We have 4 different physical-chemical properties: viscosity, whipping quality, specific gravity and acidity. So coming towards to the viscosity, so resistance against the liquid flow, so that is called the viscosity, and based on this physico-chemical properties we can determine the richness of the cream that is present over product to product. We have a different types of product, we are using the cream, and based on the physico-chemical properties the richness of the cream towards the product may varies, and viscosity it may depend upon the following factors. The first one is the fat percentage. So the percentage of fat, it may be either 20 to 30 or 30 to 40 or greater than 40. Sometimes like a butter, you can see the butter, the maximum fat percentage is 80%. So it depends on the percentage of fat that is present in the milk. And temperature, so higher the temperature, that decreases the viscosity. So the temperature is an important factor. And separation conditions, so what type of method you are going to use for the separation of the fat from the milk, either a gravity separation method or the centrifugal separation method. And homogenization, so breakdown of the fat into a uniform particles, and that is creating or breaking the emulsification process, that is homogenization. And cooling, so what temperature you are going to cool, so it is depends on the types of cream. And aging process, at what time you are holding the cream with respect to the temperature, storage temperature. And clumping, so after cooling and aging, the formation of the clumps of the creams, the size of the clumps, so it's all depends on the where either a product which is have a more viscosity or lesser viscosity. So more viscosity, the product which will flow less. If it is less viscosity, the product can easily flow. So next is the whipping quality. So beating the heavy cream with some other ingredients to increase the flavor of the quality of the cream. So beating the cream with some other ingredients with the help of an agitators to produce the froth or foam. So that is the whipping of the cream. So the whipping quality, we have some factors that is affecting. So that is the level of fat that is present in the milk. So the fat percentage should be 30 to 35%. And whipping temperature, so the whipping can be takes place at a less than 4 degrees Celsius. And separation temperatures, so the satisfactory level is 32 degrees Celsius. And aging, that is the holding the cream for several hours, that is for 24 hours at 4 degrees Celsius, that is an optimum temperature for holding. And homogenization, so 300 psi is detrimental, so the homogenization can give a uniform fat globules. You have to fix that also to obtain a good quality whipped cream. And acidity, so acidity which is reduces progressively. And addition of stabilizers that reduces the whipping of the cream. Specific gravity, so whenever the fat percentage increases, the specific gravity of the cream gets decreases. So when the fat percentage is 1, the specific gravity is 1.036, and the fat percentage increases to 10, 20, 30 and 40, you can see the differences in the specific gravity, and it reduces. Acidity, so acidity which is freshly separated cream is always lower than that of the milk, so from which it was separated and calculated by the formula. So the formula which is used to determine the acidity of the milk, so usually the milk which is present in the nearly towards the neutral acidity level, it means the pH of the milk or the acidity is, the pH is 6.5 to 6.7, and the milk which comes under the category of low acidity product. The percentage of the formula which is used to calculate the acidity is the percentage titerable acidity of the cream is equal to percentage of serum in the cream multiplied by the percentage of serum in the milk and multiplied by percentage of titerable acidity of the milk. Pasteurized at 71 to 77 degrees Celsius for 15 minutes, and it is cooled to 60 to 60 degrees Celsius before going into the plastic cream separator for the separation process. Next is the frozen cream. The objective is to improving the keeping quality of the cream for the multiple purpose. For example, to produce an ice cream or for the application of the cream over the cakes, and it can be used as a cream for the preparation of the inside the biscuits. So for the multiple purpose we are using the frozen cream. So the frozen cream, the most application is the ice cream processing, and for the preparation of the ice cream these frozen creams can be used. So to maintain the keeping quality of the cream during the transportation over long distances, and it for the ice cream manufacture by adding the sucrose and other ingredients to the cream before freezing to prevent oiling off after thawing, that is after consumption, to prevent the oiling operation. And the method, the cream is standardized to 40 to 50% fat, as I told. So before going for preparation of different kinds of cream, we need to standardize based on the level of cream. So normally the cream which contains the fresh raw milk cream which contains 33% of fat, we are standardizing towards based on the consumer preference and application. We are standardizing accordingly. So here for the preparation of the ice cream, we are standardizing the cream towards a 40 to 50% fat, pasteurizing at 77 degrees Celsius for 15 minutes, cooling towards 4 degrees Celsius and filled into a paper or plastic containers or tin can and sealed well. So we are keeping the frozen, we are keeping in a frozen condition at minus 12 degrees Celsius or below. Usually for the ice cream preparation process, we are going for a hardening process. The hardening process is, that is, minimizing the temperature for a longer shelf life storage or maintaining the shelf life of the cream for the preparation of ice cream and all. Usually at hardening minus 18 degrees Celsius, we are going for a freezing temperature to maintain the keeping quality or the shelf life of the cream for the ice cream manufacturing process, etc. And clotted cream. So clotted cream, which is the heating the cream to 70 to 80 degrees Celsius in a shallow pan and allowing it to cool slowly. So here the clotted cream, compared towards the other cream, clotted cream have more protein percentage and it can hold it for 24 hours in the aging process, and it has a more application. So surface layer consists of a clotted cream which is skimmed off and it is strained. And sour cream, so heavy bodied ripened cream of high acidity, so 0.6% level, so clean flavor and smooth textures made by inoculating sweet, pasteurized and homogenized ice cream with the culture of lactic acid and allowing fermentation to proceed until these qualities are obtained. So this is a sour cream which have a clean flavor and smooth textures by inoculating the sweet and pasteurized homogenized cream. We are adding the culture of lactic acid to obtain a sour taste, so that the fermentation process gets begin and we can obtain a sour cream at the end. And synthetic cream, so it is a mixture of flour, egg yolk, sugar, water and margarine, so vegetable fat, usually groundnut oil, and whey cream, so fat removed from cheese whey, slightly differs in the composition from regular fresh cream obtained from the milk. So packaging and distribution. So packaging, storage and distribution. Packaging, the table cream which is packed into an LDPE pouches or paper cartons and the glass bottles, sachets, plastic bottles, etc. And these cream which is packed can be stored at a temperature of 5 to 10 degrees Celsius, and especially if it is an ice cream processing, you need to go for a frozen condition. There is a freezing temperature less than minus 12 degrees Celsius to 18 degrees Celsius. And the cream is stored at 5 to 10 degrees Celsius until it reaches the consumer or until its usage, and distributed as early as possible within 3 hours of removing from the cold storage. So you should have to maintain in a cold storage condition, that is 5 to 10 degrees Celsius, before using for any other application, either for the ice cream processing or manufacturing or for the home application, or based on the consumers they getting the product from the retail markets. The purpose of cream separation. The main purpose is to recover the fat from the milk. So the fat which is settled on the surface of the milk after some time, even if you are kept undisturbed or application of the heating or cooling process, the fat can be present on the surface layer of the milk. So to recover the fat from the milk, to make a standardization process. So standardization process is adding one or more constituents based upon the product which we are going to give, that is the end product, and concentrate the milk for the production of high fat products. For high fat products, example butter, cheese, and sometimes ice cream which contains a cream that have a fat percentage of 40 to 50%, and to obtain a fat reduced or fat free milk. So if we are removing the fat from the milk, and the milk which can be sold as a skim milk, and we can obtain a skim milk powder even though. Principle of separation of cream. So based on the density differences, the fat and the milk can be separated. The fat is an oil, fat or oil, and the milk or water which can be separated based on the density differences. Usually the density of the water is higher than that of the fat globules that is present in the milk. So that's why the fat globules which can be floated and can found on the surface layer of the milk. So the density of the milk which is high, the density of the water which is higher than the density of the fat. That's why the fat which is, we can find the fat at the surfaces of the milk. So methods of cream separation. Methods for separating cream from milk is, there are two types of methods. One is gravity method and another is the centrifugal method. So gravity method, so based on the gravitational force the separation can be takes place, and centrifugal method, so based on the centrifugal force, based on the rotations per minute, the separation of the and the density differences, the separation of the fat and the milk or the water can be taking place. So is the gravity separation. So fat has a tendency to rise, as I told, when the milk is allowed to stand for some time. So this is because, as I told, because of the density differences, the density of the water which is higher than that of the density of the fat. So that's why the fat gets floated on the surface layer of the milk. If the fat which is, the density of the fat which is higher than that of the water in the sense, the fat automatically gets sinks towards to the bottom of the bottle or any other vessels. So based on the Stokes law, we need to identify the velocity as rate, velocity or speed of the flat, that is flat globules, that is rises towards to the top of the milk layer. So the equation is V is equal to 2 into acceleration due to gravity into density of the skim milk minus density of the fat into the radius of the flat globule square divided by 9 into N, viscosity of the skim milk. So this is an example. So cork is lighter than water and floats. As I told, the water have a more density, the cork have a lesser density, and stone is heavier than water and sinks. So stone which is higher in density compared to the water, so that's why it is reaches the bottom, sinks the bottom of the vessel because of its higher density and higher weight. Here an example is iron, stone and cork all have lower densities than mercury, and therefore it's floating. You can see the picture. The iron, stone and cork which have a lower density than the mercury. So here the mercury have a higher density, iron, stone and cork have a lesser density, so that's why they are floating. So this is an example for the gravity method. So the methods of gravity separation: shallow pan method, deep pan method, water dilution method. So milk is allowed to stand in a pan of 10 cm depth and 45 to 60 cm diameter at 7 degrees Celsius for 24 hours. During this time the cream rises to the surface. So this is the shallow pan method. And deep pan method, 51 cm is depth and 20 to 30 diameter at 10 degrees Celsius for 24 hours. This is the difference between the shallow pan and the deep pan, where here the cream gets rises to the surface and the skim milk which can be drawn through the faucet. And water dilution method, so milk is diluted with the water and allows to standing at 37.7 degrees Celsius temperature. Water would make the flow and the viscous, thus facilitating the rise of the fat. You can see the picture for the shallow pan method and the deep pan method. So here the height and the diameter may varies, but the separation is based on the gravitational force. And scalding method, so heating and cooling, as I told, if we are keeping undisturbed, that is based on the gravitational force, we can get the fat separately, fat and the water. But in the scalding method, and also heating and cooling also makes the fat float on the surface of the milk. So heating and cooling of milk slowly causes the formation of cream layer at the surface of the milk. And Jesse creamy method, so milk is heated at 242 degrees Celsius using hot water in the jacketed vat, and then cooled to 10 degrees Celsius using chilled water in place of hot water in the jacket of vat. So cream will be separated rapidly on cooling by increasing the difference in the densities of the cream and the serum. So based on the density difference, it gets separated. So these are the factors that is affecting the rate of rise of cream in gravity methods. Temperature, increase in temperature increases the velocity, not viscosity. Clumping, increase in the radius increases the velocity, and addition of adhesives, that is increases the velocity. And size of the flat globules, in globules size increases the velocity. So these are the factors. Centrifugal method, so the cream may be separated by using the gravity method, and nowadays in 1880 CGD Lowell of Sweden devised the first mechanical cream separator based on the principle of the centrifugal force, that using the centrifugal force the centrifugal separator gets worked. So based on the rotations, you can see the picture, we have a separator and a clarifier. So separator in the sense, it will separate the two liquids based on the density differences. Clarifier, it will separate the liquid and the solid dust particles that is present in the milk solution. So that is the difference between the separators and clarifiers. And centrifuging process, that which effects of gravity can be amplified by the use of centrifugal force to the extent that the separation process become rapid and continuous. Usually the gravitational force which is exist already, the centrifugal force which speed up the process, and continuously it separates the fat and the solid particles and the liquid water. You can see the separator and the clarifier. As I told, separator which will separate two liquids based on the density difference, and clarifier which separates the liquid and the solid dust particles that is present in the milk. And centrifugal method can be the milk that is fed into the centrifugal cream separator, and you can find the velocity by using the formula V is equal to Kr into N square into density of the skim milk minus density of the fat into radius of fat globule divided by the 18 into viscosity of the skim milk. So this is the comparison of the methods. So gravitational method and centrifugal method, they have their own advantages, but comparing towards to the gravity method, centrifugal method which is more efficient and rapid and continuous, you can obtain a higher efficiency of separation of the fat from the water, and you can recover more fat percentage in the cream comparing towards to the gravitational method. And quality of the cream, so clean milk production, cooling of the milk soon after production, separating milk under hygienic conditions, prompt cooling of cream, storage at a lower temperature, transport of the cream to the dairy under low temperature. So these are the things which determines the quality of the cream. So clean milk production and also subsequent cooling of the milk to avoid the attack of the microorganisms or any other enzymes, and storage at lower temperature, that will also retard the growth of the microorganisms and inactivates the enzymes role, and transporting cream at a lower temperature which will maintain the shelf life of the product. And as I told, the application of cream processing in the ice cream manufacturing. So first, in the raw milk, the milk, cream, milk powder, whey protein, liquid sugar, stabilizers and other sugar ingredients which gets mixed in the mixing tank, and where the solids SNF and fat percentage can be checked using a turbo oracle. Using a machine or the same smart turbo and oracle, the solid percentage SNF and the fat percentage can be obtained, and after that it is moving towards the homogenizer, where the fat globules gets uniformly distributed inside the milk. We are breaking the emulsifying process in the homogenizer, and it is moved towards the heat exchanger. The heat exchanger which exchanges the heat, that is, it will heat the milk from 4 degrees Celsius towards to a 72 degrees Celsius, and subsequently we are cooling the milk towards to a 4 degrees Celsius for the further processing. So heat exchanger which utilizes, here we usually use the plate heat exchanger for the processes, and it is moving towards to a pasteurizer where the pasteurization begins, and after that is heating from 4 degrees Celsius to 72 degrees Celsius, and then cooling towards to a 4 degrees Celsius, 4 to 10 degrees Celsius, and moving towards to the aging and storing van, and it will be kept for 24 hours, and after that it is moving to a continuous freezer. In that time you are checking the solid not fat percentage and fat percentage in the milk, and then it is moving towards to a continuous freezer where the freezing of the whole ice cream gets taking place, and after that freezing it is moving towards to the packaging section where it gets packaged, and after that it is moving to the hardening section. So the hardening section, you are reducing or minimizing the temperature from minus 12 degrees Celsius to minus 18 degrees Celsius, where there it will form the ice crystals, and then the cream have a more keeping quality, that is a better keeping quality in the hardening process, and it is moving towards to the storage distribution and it is transported at a lower temperature for further processing. So this is a flow chart which shows the preparation of the ice cream, and it is one of the application of the cream processing. So thank you so much for the time which you spent to listen the video for the cream, and I have discussed about a lot of contents that is present in the cream. So from the starting from the cream towards to the ending of the application. So cream, what do you mean by a cream, and the principles, physical-chemical properties and application, and everything about the cream which has been covered. So thank you so much for listening. Thank you.